So problem 7.71. So this problem says to repeat this problem again, but this time assuming that this dot is here. So let me see if there's a way I can just any white. I can just, yeah. There we go. Cool. Same thing as last problem, you know the drill. We first start with our ground node. This is 80 volts. We assume this is short circuit. The switch is turned. Right. This is going to be our VT, V2T, and then we do our EFC, equation for components. IT is going to be equal to 80 minus VT over 40. Then we know that VT minus V2T is going to be equal to 5 DIT over dt plus 2.5 DIT over dt. And we know V2T is going to be equal to 10 DIT over dt plus 2.5 DIT over dt. 0.5 DIT over dt is 12.5 DI over dt. Okay. So same thing. We can plug this V2T into this equation, then we plug whatever answer for VT we get into this equation. No need for maxima. So VT is equal to or minus 12.5 DIT over dt equals to 7.5 DIT over dt. So VT is equal to 20 DIT over dt, right? So then we can go ahead. IT equals to 80 or just to signal this, we're using this equation, 40 IT equals to 80 minus 20 DIT over dt. 40 IT plus 20 DIT over dt equals 80. So we simplify this. So 2IT DIT T equals 4. So then we know that tau is going to be equal to 1 over 2, correct? And our K is equal to 4. So knowing this, we're able to, we're able to find our I infinity. So our I infinity is going to be equal to 1 over 2 times 4 is equal to 2. And our I at 0 is going to be equal to 0. So plug this in, IT equals to 2, yeah, 0 minus 2 e to negative 2t. So it is going to be 2 minus 2 e to negative 2t. Right? Okay. So now we can go for v1. So we know v1. We know v1 is going to be equal to 2et minus v2t. And we know the value of each. So we know vt is equal to 20 and v2t equals to 12.5. So our v1t would be 7.5 dit over dt, v1t, correct? So yeah, v1t, and then we know the derivative of, we know it, but we can find the derivative of it. It's not that hard. It's 4, we take the derivative of this, so we get -2 times -2 e to negative 2t. So it would be 4e to negative 2t, correct? So 7.5 times 4e to negative 2t. 15, so it'd be, I think, 30. No, so 15, yeah. 30 e to negative 2t. So knowing this, now we can go ahead, calculate v2. v2 is 12.5. di times 4 e to negative 2t. 25, so 50 e to negative 2t volts. And so same thing, to verify if it makes sense, at time equals 0, KVL is going to be the same. You got 30 plus 50, because if we plug in this 0, this whole thing here turns into 1. Same thing happens here. So it does satisfy the condition, and it does make sense in terms of circuit behavior. So yeah, that would be our answer for 7.71.